Hello and welcome to another CS Tutor Center video. Today we're going to talk about the problem remove duplicates from sorted array 2. This is part of a playlist called 2 Pointers. You can find that playlist in the description of this video. But before we get started, if you are enjoying these videos, please subscribe to the channel. When you subscribe to my channel, it lets me know that you would like me to make more of these videos. Okay, let's get started. The problem says, given an integer array nums sorted in non-decreasing order, remove some duplicates in place such that each unique element appears at most twice. The relative order of the elements should be kept the same. Since it's impossible to change the length of the array in some languages, you must instead have the result be placed in the first part of the array nums. More formally, if there are k elements after removing the duplicates, then the first k elements of nums should hold the final result. It does not matter what you leave beyond the first k elements. Return k after placing the final result in the first k slots of nums. Okay, and then, so what it's saying is that we're going to have an array, it's sorted, and you can at most have 2 duplicate numbers in it. So let's come down here and look at this. So when we see this, this one has like 3 duplicates. Actually, let's look at this one. This one's a little more obvious. So here we see there's a lot of duplicates in here, right? This is okay because there's just, you can have at most 2. This is a problem because this is more than 2. There's 4. So we got to reduce that down to 2 by shifting this array over to the left by 2, which would delete these ones. And these are okay, and that's okay. So we shift this array, this part over to the left by 2, which ends up leaving this here. Now, in some languages, you can't resize the array, so that's where we are just gonna shift this over by overwriting these, and then we'll have this array. It's still the same length, but they're only going to look at the first k elements, where k is the length of the answer array. So in this case, 7 is the length of the answer, and we're going to return back 7 to tell the solution. And then they will then look over the first 7 elements and make sure that we have the right elements. So that's what they're expressing here by saying, this is what we're going to do. We're going to check to see if your k is the length of the solution array. And then we're going to loop over the first k elements of your array to see if they match the solution array. Okay. Do not allocate extra space for another array. You must do this by modifying the input array with constant extra memory. Let's look at the constraints. So it's guaranteed that there'll be at least 1 item in the array, and there can be up to 3 times 10 to the 4, and then the values are in this range, so they're going to fit in integers. And it's guaranteed that the array is going to be sorted, and we'll make use of that fact to write an elegant algorithm. Okay, let's hop over to the whiteboard. Okay, so this is from the example 1 problem. Now, if we just dive into this right now and I show you how to solve this problem, it's going to seem a little bit confusing. So instead of me just diving in and showing how to solve this problem, what I'm going to do is I'm going to show how to solve a simpler problem. And then once we understand how to solve that simpler problem, then I'll show how to solve this problem, and then it'll become crystal clear as to how this problem is being solved. This is the best way how to explain this problem. So let me create a simpler problem for us to solve, and then we'll get into this actual problem. So the simpler problem would be remove duplicates. I'll say remove all duplicates from the array in place. Okay, so the simpler problem is that we're going to remove all the duplicates from this array, and we're going to do it in place. So we're not going to create an extra array, and we're going to return the length of the array as a result. So when we look at this problem, the solution, let me duplicate this real quick so you can see this down here. That's the original numbers. The solution would be to remove all these duplicates and just you know, have the unique values be left. So it'd be like this. That's a duplicate. These are duplicates. And that's a duplicate. So then the answer in this case is we would return the value 4, because 4 would represent the length of the answer array. Now notice we don't have to worry that there's going to be all kinds of other, there could be all kinds of other numbers in here. It doesn't even matter what's in here. We're just going to return, just like our problem, the original problem says, we return the length of the answer array, which is going to be 4 here, and then all the values from 0 to the k, which k is 4. All these values need to be the correct values. Okay, so let me show how to solve this problem. First, I'll get rid of this. Okay, so I'm going to create this index v, and I'll start it here, and this index I. These will be our 2 pointers. Okay, so the v, what the v is going to represent is that all the array locations before the v, so right now there's only one array location. All the array locations before the v are valid. They're all unique. And then the I pointer is going to be what we use to iterate over the array. All right. So here's what we're going to do. We're going to say, in our algorithm, we're going to check to see if v, which is the value 1, that index, v minus 1, is that equal to this I, where I is pointing, which is 0. And it is. So we leave the v there, and this increments up. And then we say, is v minus 1, we ask the same question, is v minus 1, which is 0, is that equal to what the I is pointing at, which is 1? And it's not. So if it's not equal to that, then we'll copy the value of where I is pointing and put it where v is. And then this moves up. Okay, let me write the code real quick that shows what I just talked about. So far we have this. I'm going to do it with a while loop because it'll be better for people who are in Python to understand as well. And I'm not going to worry about declaring the values or anything. So we'll have, that starts out at 1, the v starts out at 1, and then then we have this while I is less than like nums.length. This is just pseudocode here. And then we're going to check to see if the nums of v minus 1 does not equal to nums of I. And if that's the case where it's not equal to that, then we said we want to copy what nums of I is pointing at. We want to copy that and put that into where nums of v is. And then we'll increment v by 1. And then we always increment I by 1. at the end of the loop. Okay, so let's continue on. So I'm going to step back real quick and show where we were now that we have that code. So I'm stepping back to restart the problem. And we're following this code. Okay, so v minus 1, if if v minus 1, which is 0, is that not equal to this 0? And it's not, so that v stays there. And this I moves up. V minus 1, which is 0, is that not equal to the 1? That's correct. So we enter the if statement, and we're going to copy what this I is pointing at to the v. And the v moves up. And then the I moves up. V minus 1, which is 1, is that not equal to the 1? No, it's not, so it does not enter the if statement. This I moves up. Same question, v minus 1, is that not equal to the where I is pointing at? It's not, so we don't enter the if statement. The I moves up. V minus 1, which is 1, is that not equal to the 1? It's not, so the I moves up. V minus 1, which is 1, is that not equal to what I is pointing at, which is 2? That's correct. So we go into the if statement and we copy the 2 to where the v is pointing. And the v moves up. And then the I moves up. V minus 1, which is 2, is that not equal to what I is pointing at, which is 3? That's correct. So we copy the 3 to where the v is pointing. And we move the v up. And we move the I up. V minus 1, which is 3, is that not equal to where I is pointing, which is 3? That's not correct, so we don't enter the if statement. And the I moves up. All right, now our answer is length 4. These are all the unique elements here. There's 4 of them. So the answer is going to be wherever v is left. So the answer is return v. Okay, now, now that we have this understanding of how this simpler problem is solved, now let's go solve our problem, which is more complicated. Now it says, our problem, we know, was remove duplicates from sorted array number 2, where at most 2 can be duplicate. At most 2 can be duplicate. So let's set this back up here. Get rid of that. Now we're going to solve our problem. Okay, now check this out. Here's what we're going to change. We're going to start out at location 2 instead. And instead of looking back 1, we're going to look back 2. And that's it. That's the only thing that's different with this. Pretty great, huh? So let's start out here. Let's start out here. And then we'll start asking these questions. Before I start, let me also say that there was an if statement before this algorithm that you would have in both the problems. It's just a base case to check to see if I'll write it right now. So it's this here. Okay, so this fits our problem. Nums, if the length of this is only 3, if we had an array that had only, if we had an array that only had 2 positions, then we would just return the length of that array, which is 2, because we can have at most 2 duplicates, and if we only have 2 items in an array, there's nothing for us to do. Okay, and the previous the previous problem that we solved would just be checking to see if it's less than 2. Okay, so great. So now we can look at this problem and see how it's going to work. All right, v minus 2, which is 0, is that not equal to what the I is pointing at, which is 1? That's correct. So we copy what nums of I points to, which is 1, and put it in where nums of v is pointing to, which is which is here again 1. So we copy 1 on top of itself, and then the v moves forward 1, and the I moves forward 1, and then we say is v minus 2, so 3 minus 2, which is 1, is that 0 not equal to what the I is pointing at, which is 1, and that's correct, it's not. So we copy the 1 onto the 1, and the v moves forward, and the I moves forward, and then v minus 2, which is location 2, which is 1, is that not equal to what the I is pointing at, which is 1? They are equal, so we don't enter the if statement, and just the I moves forward. So notice that the v represents everything in front of the v, which is all these, are all the valid results. They can have at most 2 duplicates. We're in a scenario right now where we just found there's like another duplicate, so the v is going to stay there, and the I is going to go search for one that's not duplicate, so that we can shift this array over. Okay, so now we are here again. We say v minus 2, so 4 minus 2, go to the 2, this is the value 1, check to see if the value 1 equals what I is pointing at. They do equal each other, so we don't enter the if statement, the I moves forward 1. And then now again, v, which is 4, minus 2, which has the value 1, so is the 1 not equal to the value 2 of where the I is pointing, and it's not equal. So then we enter the if statement, we copy this 2 to where the v is, and the v moves forward, and the I moves forward. V, which is 5, points at 5 here, v minus 2, so that goes down to 3. Is that value 1 not equal to the 3? And the value 1 is not equal to the 3, so we go into the if statement and we copy the 3 to where the v is, and the v moves forward, and the I moves forward. V, which is 6, minus 2, which is 4, is that 2 not equal to the 3, which is where the I is pointing at? And that's correct. It's not, so we copy the 3 to where the v is, and the v moves forward, and the I moves forward, and the loop ends. So now everything in front of the v is the solution. So we return the v to say this solution has a length of 7. There's 7 items in it. And let's go look at that answer here. And the answer is 7. And this is correct. We have, before the v, we have all those items in it. Okay, so that's the solution. So now we'll go code this up. Okay, first is our base case. So we have this nums.length less than 3 return. I should call it an edge case actually, not a base case. This is our edge case. So, and then now we have our v. So I'm going to call this valid num index. And then we'll have our I, starts at 2 as well. If nums of, just copy this here, valid nums index minus 2 not equal nums of I, and then nums of valid nums index equals nums of I, and then return. Okay, and then we'll submit that. Run it first, checks out, submit it. Okay, great. So that beats, that's nice and fast. We have a linear time complexity and we did it quickly too. So now we'll switch over to the Python version. I'm just going to say V, it'll be less typing for me. Whoops, misspell. Okay, great, and that also passes. If you are enjoying these videos, please subscribe to the channel. That lets me know that you want me to make more of these videos. And this is a playlist. This is part of a 2-pointers playlist I made. Check the video description to get a link to the playlist. Have a good day, and I'll talk to you later.